Hey there, welcome to NASA Launchpad. I'm your host, Amber Whalen. Okay, so you know that mass is the amount of matter in an object. Kind of a simple concept, right? An object's mass doesn't change due to the gravitational pull. That's weight. But the mass of an object does have relevance to several other properties. And those properties are called, wait for it, mass properties. Now, what are these properties and what do they mean? Well, to answer that question, who better to turn to than Amanda Cutright? She is the Mass Properties Working Group lead supporting the Orion Flight Test Office through the Abort Flight Test Articles project. That won't fit in the lower third title, so we're going to call her a mechanical engineer, which she is also.
When I mention mass properties, there are a lot of different properties contained in there. The ones most commonly known are the mass, and then there's also a center of gravity. So that's kind of the point where that mass could basically be reflected in one point. So if you were balancing it on a knife, that center of gravity is what you would need to put over that knife to make it balanced. And there's also an inertia component, which is a function of the mass and how far away that mass is from the center of gravity or the point that you want the inertia is about.
So, let's recap real quick. The two big properties that Amanda mentioned, besides mass, are inertia and the center of gravity. Go back to Newton's first law. An object at rest stays at rest, and an object in motion stays in motion at the same speed and direction unless some new force comes on the scene. Let's face it, the only way you're going to get off that couch is when some outside force drives you to do so, like hunger, your mother yelling at you, or nature calling. That's because all objects really hate to change what they're doing without a good reason. And that's something scientists call inertia, or the resistance of an object to make change in the state of motion. But the higher the inertial mass of an object, the larger the resistance to changing its state of motion. So, if you had two objects with different masses, the object with a larger mass will experience a smaller acceleration, and the object with a smaller mass will experience a bigger acceleration. The center of gravity is another important property. Remember that gravity is pulling equally on all parts of an object. So an object's center of gravity is the point in which the system's weight is balanced. But keep in mind, the center of gravity doesn't always correspond with the geometric center of an object. For example, the center of gravity in sports cars would be designed low to the ground to make for better handling on sharp turns, while the center of gravity in a big truck is much higher, making sudden turns a problem. Where do you think the center of gravity is in some of these things? Those properties affect how something flies. Here's Amanda again to explain.
Those specific properties affect flight from a lot of different perspectives. Probably the main ones are the aerodynamics and the flight dynamics. So the path or trajectory the object is going to take, which also then goes into the avionics or the flight control systems that go into the article. And it also gets involved from a structure and load standpoint. So the mass and that center of gravity affects how much load is going to be applied to certain components of the system.
But are those properties going to be the same in a flight test article? For example, in the Ares 1X flight test article, certain components aren't going to have all the same internal systems and structures that will go into the final Ares 1 vehicle. And of course, there won't be any astronauts going up in the Ares 1X. This seems to be a challenge for engineers. So, how do you handle that? Amanda?
So as a mass properties engineer, a question that comes up a lot is, are we actually accurately representing in our flight test articles where the astronauts are sitting and where their beds are and all the different components? So the answer to that question is that the operational vehicle will have all of those systems in there, the astronauts in there, and therefore has a resulting mass and center of gravity point. For our flight test articles, we have to end up with the same mass and center of gravity point, but we have a different structure and different subsystems in there. So in our particular case for the Pad Abort 1 flight test, as well as the next flight test, which will be Ascent Abort 1, we have thousands of pounds of ballast that we use to get to that mass and CG requirement.
So if they're putting ballast in, or some random heavy material added to help stabilize the object, that's got me wondering how these flight test articles compare to their final counterparts. Well, it depends. Different flight tests have different goals and objectives, so not all parts of the flight test article need to be identical. And in some cases, the materials used may not even be the same. Let's let Amanda explain.
So what you see behind me is the heat shield for the Ascent Abort 1 flight test, and I'll use that as an example for something that we do on all the components that go into those flight tests. We have a CAD model that represents, computer-aided design model that represents the ideal heat shield, so the density of and the shape of that particular part. But we actually take a measurement of what that actually weighs and we compare it to the analytical model. So for Mass Properties, we have both estimates that come from a variety of areas as well as the actuals for each component.
Thanks, Amanda, for all the information. Testing and retesting, looking for the best answers. And you thought draft versions ended with freshman English. Well, that's it for this episode. I'm Amber Whalen, and we'll catch you next time on NASA Launchpad.